one more example to understand the concept of reference frames, that is inertial reference frames, non-inertial reference frames, and pseudo forces. In this example, it has been asked that there is a frictionless wedge. This is a wedge, we can name it. This is ABC, is a frictionless wedge or inclined plane. Onto it there is a block of mass m. It has been asked, that is, what is that acceleration so that this block of mass m is stationary with respect to the inclined plane. There is going to be one value of acceleration for which this block will be stationary with respect to the inclined plane. If the acceleration exceeds that value, when the acceleration is more, this will move up. And if the value of acceleration is lesser than that particular value of acceleration, this will move down. So we have been asked, what is that particular value, what is that typical value of acceleration so that this block is stationary with respect to this inclined plane. So let's try to do it both ways, using the concept of inertial frames and using the concept of non-inertial frames, and then obviously match our answers. So first is, let's use, this is for inertial reference frame, this is a diagram which has been drawn. Where is the observer? Observer is here on the ground, so this he makes inertial or non-accelerating reference frame. This is an inclined plane, acceleration is like this, the whole thing is going with one acceleration. It means this block is stationary with respect to this. It means this has acceleration A only in this direction, not moving up, not moving down. Had it been moving up and down, there would have been acceleration of this with respect to this. Because the acceleration of mass m is 0 with respect to the wedge, and that is what has been said. That is, it is not moving with respect to it. It means acceleration of this is 0 with respect to it. So whatsoever is the acceleration of this wedge, the same is going to be acceleration of this mass. The acceleration of wedge is only A along this x-axis. If we make x and y axis over here, so acceleration of this wedge is purely A along this axis. Similarly, the acceleration of this mass m should be only A along the x-axis. Now what we do is, we draw the forces which are acting on the body. Onto this body, onto this mass m, there are only two forces which are acting. One is mg directly downwards. Mg will always act vertically downwards. Mg, that is earth, is not bothered which way the block is moving or the body is moving. Earth will always apply the weight vertically downwards, straight vertically downwards, not at an angle. Mg can have components in different directions, but mg will always act vertically downwards. So mg is acting this way. As this is a frictionless surface, so there is only going to be normal reaction, that is perpendicular to this surface, perpendicular to this surface. That is, this and this surface, they are going to be at an angle of 90 degrees. So this is normal reaction. Now we see that this block moves purely along the x-axis with the acceleration A. So what we do is, we break these components n along the x-axis and along the y-axis. As we have done earlier, that is, the angle between the two intersecting lines is same as between their perpendiculars. That is, if there are two lines, this and this, there are two lines, the angle between them is theta. The same angle will be between their perpendiculars. Perpendicular to this is, this line is perpendicular to this. To this, it is perpendicular. So whatsoever is the angle between these two, the same should be angle between these two. So if this angle is theta, so this angle is also theta. We know that is how to resolve the vectors. We have done many times in our earlier classes. So this is n. So this comes out to be n cos theta, this comes out to be n sin theta. So this is n, this comes out to be n cos theta, this comes out to be n sin theta. And mg is acting vertically downwards. So along the y-axis, we have one force n cos theta in the upward direction. So along the y-axis, we have n cos theta in the upward direction and mg in the downward direction. And along the x-axis, there is an unbalanced force n sin theta, which is responsible for acceleration of this block along the x-axis. So this person, when makes the equations, he says to him, this block is stationary along the y-axis. It is not moving along the y-axis, this is stationary along with this. So whatsoever the acceleration of this block, it is purely the same A along the x-axis only. Along the y-axis, there is no acceleration to block. So he says this reference frame, the person on earth that is making an inertial reference frame or non-accelerating reference frame, says that is summation of forces along y-axis equal to 0. That is net force along y-axis equal to 0. Acceleration on y-axis is equal to 0, summation of force along y-axis is equal to 0. So that's why upward force should be equal to downward force. That is n cos theta should be equal to mg. That is n cos theta is equal to mg. Equation number 1. Second, he says that is this block is moving this way with the same acceleration as that of the wedge. So it must be having acceleration A this way. So that's why this force, the force n sine theta, is responsible for its acceleration. This is the Fx. Fx is equal to m into ax. What is Fx? Force along the x-axis. Force along the x-axis, unbalanced force along the x-axis, n sine theta. There is no force to counterbalance this force. So n sine theta is the force along the x-axis. So n sine theta is responsible for acceleration on the x-axis. N sine theta is equal to ma. Fx is equal to m into ax. Fx is n sine theta. M, ax is a, n sine theta is equal to ma. So this is equation number 2. If we divide this equation number 2 with equation number 1, we get a by g is equal to sine theta by cos theta, that is tan theta. So a by g comes out tan theta, or a comes out to be g tan theta. So it means that is if you give acceleration g tan theta to this block will be stationary with respect to this. If theta is, let's say theta is 30 degree. So we know that is tan 30 degree is equal to 1 by root 3. So in this case, if theta is 30 degree, then the acceleration is g tan theta, that is g into tan theta, that is g by root 3 meter per second square. If you give it an acceleration of g by root 3 meter per second square, this block will remain stationary with respect to this inclined plane. Let's understand the same example using accelerating frame or non-inertial reference frame. So now our observer is accelerating. So what we do is, the observer who was standing on the earth, he comes, jumps and sits on this wedge. If he sits on the wedge, it means that is this observer is also accelerating along with the wedge. So it means that is he is accelerating reference frame. So when the observer comes and sits over here, he is also accelerating along with the wedge with the acceleration A in this direction. If he wants now to apply laws of motion, there is a requirement, there is expectation from him that in addition to all the real forces he cannot touch, that is in addition to all the real forces, he will apply onto the block whatsoever he is observing a pseudo force, fictitious force, imaginary force. That is, he is not going to disturb, that is n and mg, that is he cannot disturb these real forces. Real forces, they cannot be touched, they cannot be disturbed, they will be as that is they are being applied in the earlier case, n and mg, but there is going to be one pseudo force which direction is opposite to the direction of acceleration of this person. This person is accelerating this along with the wedge. So he will apply a force in this direction. The direction of pseudo force is opposite to the direction of acceleration of the observer. Observer is accelerating this way, so the pseudo force direction will be opposite to it, so that's why it will be in this direction. And the magnitude of this pseudo force will be mass of this and acceleration of this person. Mass is m, acceleration of this is same as that of the wedge, so acceleration is a, so the pseudo force is m into a in this direction. So this person, take into consideration all the real forces, he has also taken into consideration a pseudo force also. So now he is competent to apply laws of motion. So what he does is, that is once again, that is n is broken into two components as we have broken earlier into its rectangular components. One is n cos theta, the other is n sin theta. Ma is here, this is with red mark, this is Ma is here. Now this person is competent to apply laws of motion, and what does he observe? He observes that this block is stationary with respect to him. So it means summation of forces along y-axis is equal to 0, that is net force along y-axis is equal to 0, and similarly net force along x-axis is also equal to 0 because this block is stationary with respect to him. So he says n cos theta is equal to mg, that is n cos theta is equal to mg, summation of force along y-axis is equal to 0, And similarly, along the x-axis also this block is not moving with respect to him. So n sine theta, this force is equal to this pseudo force. So n sine theta is equal to ma. You divide the two, a is equal to g tan theta, this and this answer matches.